Welcome. Welcome back to my channel Conquer the Fear. In today's video, we are going to discuss about one of the interview experience with CAPCO. So this is one of the L1 round and the candidate got selected with a package of 24 LPA. In this video, I am going to disclose about all the questions which are asked in that particular interview questions, which will be helpful for you to prepare for your next interview. Make sure you are watching this particular video till the end because I am going to explain each and every questions in details. Okay. So before going out, I would like to disclose that I have segregated this particular video into different section so that it will be very helpful for you to understand in what section what kind of interview questions are asked. So the very first thing is concurrency and the exception handling. The very first question was asked about, do you know what is fail safe and fail fast? Now if you have aware of like what is fail fast, right? So it is a behavior which is causing the application to immediately stop it, right? So whatever you are, the moment it detects an error, it is going to stop it. Okay. So typically when you're dealing with collections or iterators, you are going to get this. So let's say there are many collections like array list is there, hash map is there. So these are all fail fast. So when you're trying to do multiple operations in multiple threads concurrently, it is going to happen, right? So if your collection is getting modified in between over the iteration, let's say you are adding something, you are removing something, so this will throw a concurrent modification exception. So this is a called fail fast approach. So it is going to detect some modification has happened and it is going to immediately stop that. Okay. So give an example. If you see there is a list over here, I've added something over here and I'm iterating over here. Now in middle I'm trying to add something over here. But if you see the moment I call the iterator.next, it is going to throw a modification exception. So the benefit of using this particular fail fast collection is that it is going to quickly detect there is some problem. Second, it is going to immediately throw an exception so that you can handle that. Now, when it comes to fail-safe, this is the opposite, where it is going to check your behavior where the system is trying to continue to run, and then it can provide a fallback or a safety mechanism to avoid some crash or the entire application to shut down. Right. So even there are some errors, it is going to gracefully handle those. Now with concurrent packages or concurrent collection, there was an introduction of copy on write array, concurrent hash map. These are the fail-safe collection. So if you try to modify something while iterating also in a multi-threading environment, they will not throw a concurrent modification exception. So what happens inside this or beneath is that they are going to make the copy of that particular underlying collection, and then it is going to iterate over the snapshot of the right. That is, it will not fail in that case. So if you get an example over here, the copy on write array list I've created, I've added some element over here, I'm iterating over here. But when I'm trying to add something, it is not going to throw that any exception over here, and it is going to print this thing. So this will continue to do modification. Also, there will be no exception or failure inside it. So that is a benefit of using this concurrency package. The second question is like it was a scenario based, so you would wanted to understand like let's say you in your team like there is an encountering where the concurrency, there are a lot of concurrency issues, right? While multiple threads are trying to access the same shared resources. Now this can also lead to a inconsistent, right? So what is the fix for it? How do you diagnose it, right? The very first thing what you have to do is that you have to fix this particular concurrency issue, right? So you have, when you're dealing with multiple threads in a share excel, so there are two possibilities. One is using the synchronization and one is using the lock. So if you are making use of the synchronized method or a block, you have to ensure that only one thread is able to access that particular critical section at that particular moment. Okay. How to do is that we have to make that particular method as in synchronize, and then you have to write your code underneath that. Now, if you're using the lock, you have to make use of certain locks which is provided by the API. So there is one of them is re-entrant lock. So this is one of the most flexible way to synchronize. So it will give you more control over the locking mechanism. So you can create a lock over here. You can start the lock and then try to perform your activity. And after you've done that, you can finally release that particular. So by using the unlock method. I hope you got this particular question. Now, the question was asked about like, have you worked on the executor framework? Now, you must be already knowing that it was part of the Java 5 version release. So it is a way of trying to manage different threads and tasks efficiently. So instead of you manually creating and managing your threads, you have to execute this particular executor framework. So it is going to give you an high level replacement that a decoupling of task submission, the mechanism of how the each task will run and execute it. Okay, so the base interface is executor. So this is the main interface which is going to execute your task. So it has got different methods like which is going to take like execute, right? So it is going to take as an input as an runnable. So it is going to submit some task to it, and then it is going to execute it. Okay. So the one thing about this particular interface is that it is not going to return any result. So and it is also not going to handle any exception. So that's one of the disadvantage, but this is one of the way where you can use it. Now, if you see the interface I've already discussed, it is going to be the, let's say you are implementing a service, right? So it is going to implement the it is extend the executor. So this will give you more manageable and the control of the life cycle of the particular task you're going to execute. Okay, so there is also a submit callable task which is going to return some result in a advanced, I mean in opposite of what execute the execute method, right? So it is going to gracefully shut down your executor gracefully. There are some common methods, okay, in this particular service interface. So one is submit method, which is either it will take a callable or runnable task as an execution. Second, it has got an invoker. All this is all like with the collection of callable tasks. Okay, which is going to execute it, and it is going to return a list of future objects. So make a note of that. Now it invoke any it is going to execute the collection of the callable tasks, and it is going to return the result of one of the particular thing which is already completed successfully. Now shutdown is going to order or initiate something where it's going to shut down. Okay, so whatever the task you have executed, it will be shut down. And after this particular thing, it will be it will not accept any new task. Okay, that's the this one. Thread pool executor. Now you must be already knowing it is used for implementing the executor service. So it is going to manage the pool of threads whatever you have created, right? So it will be executed in a synchronous way. So there will be different parameters which will be applied to it, like core pool size, what is the max pool size, what is the queue capacity, etc. So you have to take care of that part. Okay. So the next thing is scheduler executor service. Now this is one of the sub interface I would say that is going to use for scheduling the now, whatever task it has to be scheduled, right, at a fixed rate or a fixed delay, this execution policy it supports. So there are different methods like schedule is there, schedule at a fixed rate, schedule at the fixed delay. So this is going to be executed in certain intervals, I would say. Then we can have the executor utility. So this is one of the factory methods which are going to different types of services, like it can include the fixed pool size, the new cache thread pool size, then single threaded thread pool executor. They can actually increase the pool size as well, so you can create a pool size and then execute the task. Okay, so there are different methods to for this particular executor framework. Now here is I given an example over here. If you see at this, I'm going to create a thread pool of two, right? So if you see, I've created a fixed thread pool, and then I'm going to submit that particular task under that particular submit callable task, and then it is going to ultimately return. So at the end also, if you see, there is an executor dot service which we already discussed, which is going to gracefully shut down and it is not going to accept any new task. The next question is about have you handled the exception handling and how it is working? Can you tell me the hierarchy? Okay. So if you see, if you look at the exception hierarchy, this is going to handle your runtime errors. It is going to allow your program to continue to execute without being terminated in abruptly, right? So this is one of the best and the robust way of mechanism to handle your exception handling. So there are try, catch, and then there are throws, and then finally keywords which supports the exception handling in a different way. So if you look at the hierarchy, at the very top or at the very hierarchy of this particular structure, there will be a throwable class which is divided into different errors and the subclass exception. So if you go to the very first thing, what is throwable? It is one of the root classes of all the errors and the exception. So this is the super class. Now if you know the super class in general, there is an object, right? But in terms of exception handling, the throwable is the super class for it. Okay, that can be thrown up. Now I've given you an example where what example there are through in this particular thing there is a class throwable, then there are different errors and the exception inside this. Now, secondly, if you think about what exactly after the throwable, right? The next section is about error. So it's one of the subclass of throwable. So this is going to represent certain serious issue which are you cannot recover. Okay. So typically when you have some problem with the JVM system resources or there is a hardware failure, right? So which cannot be revoked. So in this case, you cannot handle it or you cannot catch this particular exception of the application. Okay, so let's say the example of it is in out of memory stack flow error, overflow error, you have virtual machine errors, etc. Okay, so these are the kind of errors which we need to this error is about. Now then comes exception. This is also an subclass of throwable. So this is one of the condition which is going to catch some, like let's say some exception has happened. Now you want to catch it and then you have to handle it very gracefully. So this can be a runtime problem or a condition that is not expected in a such way, and then you can manage that particular thing. So let's say you does not find a file. Let's say there is some network issue, right? So these are the exception which are categorized into different, I would say, cached exception and unchecked exception. Now, if you look at the checked exception, these are again the subclass of the exception. So if you're looking at this, right? The hierarchy is going from right from the throwable to like the checked exception and the unchecked exception. Now, if you look at this particular unchecked exception, this is going to be either you can either catch it or either you can declare some method to hand it over to the subsequent calling method that is using the throw method. So IO exception, database error, these are the exception which are expected to be handled and in a graceful way. Now IO exception is there, SQL exception is there, class not found exception is there. These are the exception which can be handled in the gracefully in the try, catch, and finally. Now, if you go to the unchecked exception, this is also in subclass of runtime exception. So now these are not required to be declared or caught because they're typically programming errors or some logic flow errors that can be often avoided through some better practices. But this happens. Now these are exceptions. Usually, like there is some bug in the code, like let's say you are iterating over the index and then you are trying to access an element or iterate which is not there in that. Or let's say you have an null pointer, null reference, and you're trying to reference that and you're trying to access it. So null pointer exception is there. Array index out of bound exception, arithmetic exception, illegal argument exception. These are the unchecked exception basically. Okay. Now if you see here, there is a division which is happening A and B, right? So if you're trying to divide it by the zero, this is going to throw an arithmetic exception. The next question is about, let's suppose you are working on Java application and there is a throwing a null pointer exception in your application at the runtime. So how you can identify what is the root cause of it, where this particular exception has been thrown, and how you can solve it. Now null pointer exception, when it is occurring in your application, right? So it is going to perform some operation on top of that particular object whatever you're trying to reference, that is currently null. Okay, so when you're invoking something on that particular method or you're trying to access a field, it is going to throw an exception. Now there are some common runtime exception where you can add, you can find the source and then you can essentially resolve it. So the first thing is that what you have to do is that you have to identify and then you have to solve that particular thing. So first thing, you have to examine the stack trace because when you are having that particular exception being thrown, that definitely it will be logged into the logs. So you have to get that particular stack trace. So first you have to identify where this particular null pointer exception is being thrown in that particular exception stack trace. So when an exception is thrown, okay, it is going to provide a detailed stack trace which is going to cause it. So you have to look out for the cause by things where you will get all the details. So the exception type is like, it will give the details like what is the null pointer exception, what is the line number it has got the exception thrown. Okay, so you'll have, if you see the example, it is throwing null pointer exception over here, and then if you see it is given the line number as well at where exactly this particular thing is going to is throwing an example. Okay, so how to resolve this? We can make you, if you go to the line that is 42 or 45 whatever indicating there, you can identify if the object is null or not, and then you can handle it. Okay, now you can also check for the null references. The best way to null pointer exception is using the it is important to check that particular variable, right? So we have to ensure that that is not null before you're trying to use it. So this is one of the common problem which people avoid doing it. uh, so if you go to that, right, so if you see the my object is null, and then what you are trying to do, it is trying to access that particular method, and there will be a null pointer exception. Okay, so let's say the another example is, let's say you have an array which is of null, and then we are trying to get the length of it. Okay, in that case also it will throw an exception. Let's say you have null reference object, and then you're trying to accept some field also, in that case also it will throw an exception. Now, what you can do is that you can add the null check before the usage. Okay, so to avoid some exception to be handled. Now, if you go to this particular thing, right, if I'm trying to check that the null, if it is there, right. Now, apart from like how you handle like the null check, right, there is a better way to do it. After Java 8 there was an introduction of an optional, so which is going to handle your null in a better way. So it is going to handle it very gracefully. So it is going to explicitly check for like the value is present in that or not. Okay, so you can create an optional using the off null. So there are different explanation or different I would say features which are available in the optional. So when you go to this particular optional, right, it has got different methods. It has got off, it has got off nullable. So it is going to, based on your requirement, you can use it. Okay, so you can have different utility methods which are provided inside it. So it is going to check if there is a value is present or not. It is going to, then only it is going to execute. So how you can debug this particular application is that, let's say if you are from the source you are not able to, from the null pointer it is unclear, right, you can debug step by step through the code. Okay, so you have to set your breakpoints. Let's say you are using any at the id, you can easily able to set the breakpoints and examine that particular variables where exactly it is causing the exception, right? So IntelliJ provides a very better way. Eclipse is there, which is going to allow you to debug that. So make sure you write that. And the best thing is that you have to add that particular logger statement in each where you suspect the particular error to be happening. Okay. So in that you will be able to identify where the example, issue is coming. Okay. The last thing is that you have to make use of this particular require dot null to objects that require non-null, right? So it is one of the method which are provided by the Java objects to explicitly throw a null pointer exception. To this you can throw a null custom message in that particular, the variable is null or not, right? So you can make use of this. So it's one of the best way to clearly indicate that null is not the value which has to be expected, and then you can handle it. Okay. You have to check for the initialization of an object. Okay, so ensure that all the objects are properly being initialized before they are trying to access it. Okay, so if you expect an object to be initialized up but it is null, then it will cause an exception also. So make sure your everything before you're trying to access it, it has got an object availability. Now make sure you're using the constructor injection. Okay, So when you're trying to objects are ensure that it is not left uninitialized. Okay, so you have to make use of that particular constructor injection. Okay, now let's move on to the next section, that is Java 8 and features and the stream API. Now the very first question it was asked about is that have you ever worked on the Java 8 and what are the important features. Now this is one of the important question, and I cannot emphasize on the significance of this particular question, because this can also cost you a job, right? So because if the person who is interviewing you, right, he will definitely try to understand you are aware of the basic concepts of Java 8. Okay, so let's say when he asks you about, like, have you worked on Java 8? Yeah, definitely you have to mention that you have worked on it, and you should be in a position to explain each features, right? So let's say the Lambda expression was introduced, Stream API was introduced. There were different default methods in the interface. There were functional interface, which is one of the important topic. Method references, optionals class. We already discussed prior to this in the section, right? There is a new date and the time API which was introduced. There are Nash on I would say JavaScript engine that was introduced. Completable features are there. Some enhancement collections has been introduced. So make sure you are well prepared of this. Okay, and in each of this particular tuple you gain a expertise in that, so that you are not limited to just answering. You just answer it with the explanation as well. Now, what are the different types of functional interfaces we have? There is a lot of functional interface. Now, when it comes to there are two types. Like prior to Java 8, there were still functional interface already available, right? They're like runnable and different things. But post Java 8, there are different functions which were introduced. Okay, there's an interface. Now, if you look at this particular predicate, right? So this is going to test your condition whether it is going to satisfy that particular condition, and then it is going to return a stream on that part. Then comes the function. It is going to transform your functions like into something else, right? That is one of the way. Consumer, it is going to perform some operation without it is going to return any return result. Supplier, so basically it is going to produce some result without some input is being given to it. Okay, now there is unary operator, there is binary operator, there is by function, there is by predicate, by consumer, and then runnable, which is going to be previously compare already been existing also. So make sure you are prepared in this particular section. Okay, now can you tell me what is stream pipeline with respect to the stream API and how it works internally. Now, when you look at the particular component of this stream API, okay, so it is a pipeline. Okay, it is going to be consist of three main parts basically. The first part is source. Okay, so where this particular source or where this particular things is being usually referred. So ideally it is has to be a collection like set, list, or any of the array, or let's say you are trying to take it from an input from the channel, right? So you have to take the input from there and you have to convert that particular thing to a stream. Okay, then only the next step of intermediate operation and the terminal operation can be performed on it. Okay, so for the second thing is that intermediate operation. Now this is going to be transform your stream to certain, like you're trying to do some filter maps or you're applying some intermediate operation. So again it is going to be a producing the stream, but this is going to be a lazy operation, because until you're not calling the terminal operation, this will not be invoked. Let's say you are doing some intermediate operation, it is going to again return a stream, but until you are not calling terminal operation, it will not get called. Then you have some different I mean, I've given an example, like different like we have filter, what exactly the condition is, like you have map sorted, right? For example, if you see, want to filter with the name of the, which is going to start with A, then you can filter some fields, and then you're going to convert it into an uppercase. So that's what the filtering happens, and the intermediate operation happening inside it. Then comes the terminal operation. So this is going to trigger your processing of that particular pipeline, and it is ultimately going to give you a result. So it can be either you can collect it into a list or set, or maybe you can for each, and then you can produce the result, or you can convert it into or reduce it to certain things. So these are the operations which are executed on top of that particular intermediate operation. So we have collect, forage, reduce, count. There are different things. Okay. So this is the stream pipeline flow. So we already discussed the source is required, then the intermediate operation, and then you perform the terminal operation. So these are the important steps. Now, what is the difference between the map and the platform? I would say this is one of the important questions, and this will be out of 10. I would say 9 interview questions or interview will definitely have this particular question. Now, what is map? Now, this is going to transform your each of this particular element individually, and then it is going to ultimately return a new collection, okay, of the same size, okay. Whatever you are performing on the same operation will be applied in the particular each element. But when it comes to flat map, this is similar to flat map, but it is going to flatten your result basically. Now when it comes to transforming, right, it is going to return some elements, each elements into a flat map, and it is going to combine in this particular single collection, okay. So if you see map, it is going to perform individually on that particular collection elements, and then in the flat map it is going to collectively cause you to into a single collection. Now let's move on to the design pattern section and what are the solid principles. Now if you look at this, I would say be thorough with the design patterns, because uh, not only limited to the singleton, or I would say there are different sections, right? Behavioral is there, structural is there, different type of design patterns are there. Now you make sure you are well prepared, not only like common interfaces like singleton. Now this is, don't expect that every time like the person will ask you about singleton only, right? You have to be well prepared with the design patterns, like whether it is structural, creational, or any behavioral thing, right? So make sure you are preparing all of them. So I've covered some of the important one, like singleton is there, factory is there, observer is there, strategy is there, decorator, adapter, facade. So these are all the design pattern which you have to be well prepared, well versed, because what happens is that not only like there is continuous sequence of questions which are asked. Like say he asks you a singleton, right? Now he'll not stop you whether you know a singleton or not, how to implement it, but he may ask you what is the use of it, why do we need to use it, in what scenario we need to use it, right? So make sure that you are all prepared with the overall related questions which might come as a subsequent question, okay. Because the challenge is that, right, everybody answers the question what is singleton, but there are different, let's say for an example singleton itself only, right? Now there are different ways to break it. Like what are the different ways to break it, what is the best way to write the singleton? Like you have a double checking way, like there is a enum way, right? So you need to be very very well prepared on it. So you have to master that particular individual design patterns. Now we already discussed what is double checking, and I like, just made a note of it, right? So what is, like when you're dealing with the singleton design pattern, right? So this is one of the technique which is used in singleton design pattern to ensure that there is a thread safety. Now when you are dealing with synchronization process, this will reduce, or it will minimize your synchronization process, and it will give you a better way to handle it. Now, in short, first it will check. Now, if you look at this particular code, right, if you see there is a first check which is going to happen is that the null instance is null or not. Second is going to apply a synchronized block over that particular on that particular class, and third it will again check for that the instance is null or not, because now this is the second time we are going to check if it is null or not. That's the reason it is called double checking, right? Double lock checking. So after that only it will going to create an instance. Now we can make use of this particular volatile to ensure that there is a proper visibility amongst the threads, because that's what the benefit is about. So now let's say you want to design some Wi-Fi system in your college or anywhere, right? How you can actually design it, and what are the design pattern what you can use it. Now, when you're designing a Wi-Fi system in the organization, you have to restrict certain websites. Let's say you have some YouTube or something. So what you can do is that we can make use of the proxy design pattern, which is one of the best choices for this. Now, what happens is that it is going to be a surrogate or a placeholder. You can have that for controlling the particular resources. Now, in the website, let's say you have some cases of website. So what you have to do, you have to implement a web access proxy. This is going to intercept your request into the website, and then it is going to check if it is the sites are allowed or not. So it is going to either allow it or either it is going to block it. Okay, so you will have real subject over here, which is going to be the actual web service, the proxy that is going to intercept and filter the access to the web. So it is going to check the requested URL, and then it is going to restrict that particular website like YouTube or media store, right? So this is the approach. Now basically I've given you an implementation over here. There is an real internet class written over here, and then you have to I've restricted, like now I've checked it is a restricted site or not under that particular connect method. If it is not restricted, it is going to be this one. It is going to connect the site. Okay, so that's what the design pattern we have to implement. Now let's say what is it solid principles, and what are the solid design principles. Now you must be already knowing there are different five characters. For each of this particular character there is a different principle. So one is solid principle, which is which deals with having only single class for one reason to chain. So it is going to only do one set of operation or one job. It is going to take as a responsibility. Okay, so that's the way. Now, if you're going to look at the second thing, that is an open close principle. Now, this is one of the principle which says that it is open for extension and closed for modification. Okay, let's go principle. Now, this is one of the, I would say, let's say object is a superclass, right? It should be definitely be replaceable with these subclasses, like which is not going to impact your functionality as a whole, right? So you have to deal in such way. So Lisco principle is about that. Now it has interface segregation. Now if you look at this particular things, right? Now you should not, or the client which is going to invoke, right, is it should be not forced to depend on certain interfaces which is they are not irrelevant, they are relevant, not relevant to them. Okay, so you have to always create a system which has got smaller specific interfaces which are custom tailored to the client. Now, dependency inversion, I would say this is a high level module which should not depend on the lower level module. So you always use the abstraction. Okay. So it is going to be the abstraction which is going to be dependent on none, but instead of the implementation, I would say. Now let's move on to the section of Spring Boot and microservices, because this is one of the important and I would say must section you should be well prepared of. Now, what is how you the Spring Boot application works. Now, if you know, Spring Boot is one of the popular framework which is used for building web application in a very quick way, with a very minimal configuration. Now, what first is the first feature about is that auto configuration. It is going to automatically configure your application components, like you have database, security, etc. You have embedded servers. Now you have like Tomcat or Jetty, where you can underneath the embedded server you can deploy your application. Third is like Spring Boot Starter. Now this is a pre-configured dependencies which are used for different functionalities. Like let's say you have a web project, you have data, you have a security project. We can use it for Actuator. This is going to be a production ready feature, which is like going to check some health checks, matrices, and monitoring features. Now, if you want to do the rapid development with respect to the microservices, you have REST API and enterprise applications. Spring Boot provides the best ecosystem, I would say. Now, we already discussed like how to handle exception in Java, but when it comes to Spring Boot, right, it has got its own way to handle this particular exception. Now, it is handled in a very clean and a centralized way. Basically, we have to make use of the annotation, that is controller advice and the exceptional advice handler. So basically, at the very global level, you have to define the global exception handling, that is, a controller advice. So this is going to handle this particular exception at the entire application, I would say. So anywhere in the application there is a exception happening, it is going to take care of that. Underneath that, you have to define your exception handler over here. So let's say you have resource not found exception, which is throwing you want to handle that particular exception. What you have to design is that you have to write a method that you have to gracefully handle this, and you have to tell them, like, what you have to return in that case. So the return status, what you are doing, let's say you are returning not found, you have to design, you have to return the response entity with that particular message. Okay, let's say you want to, in generally, let's say you are not able to specifically define what kind of exception you want to handle. So in general also you can define, and then you can handle that. Third, you can create your own custom exception also. Let's say you wanted some specific exception to be defined for your client, right? Or you want to define for a some specific behavior, you can define in this way. So you have to extend that particular runtime exception, and then you create your own class. Exception handling at the controller level. Now you can define the controller level exception handling over here. So at the rate exception handler, what we already discussed, right? You can use that. Now if you see here under this response entity, we are throwing something over here. If the null, if there is a null, right? So it is going to throw that resource not found exception. Ultimately, it is going to that particular controller advice method, and it is going to handle it. Next question is about how to enhance your performance with respect to caching, right? How do you implement that in the server side, in the client side? Okay, in the Spring Boot application. Now, uh, when you're trying to integrate a caching solution in the Spring Boot application, okay, there is a we have to make use of the Redis, cache, or concurrent map, right? Now let's say you're dealing with the server side caching. Okay, so Spring provide a Spring cache. So there is a built-in caching support which is provided with the annotation. Now let's say you're using Redis or cache. uh, First you have to do is that you have to add the dependency. Okay, after that what you do is that you have to enable that particular caching at the application level. So there is a main class at the right enable caching is your annotation which you have to enable. Now then after it comes the configuration with respect to that. Now let's say you have to configure where your Redis is hosted, where that particular port is enabled. Okay, what are the different type of cache you are using, and then you come to that particular service level implementation where you try to have that particular at the rate cache per annotation defined, and the implementation what you want to try to achieve here, you can write the logic over here, and this particular method will be cached up, and it will be loaded from that particular memory. Now, client-side loading, we can make use of the HTTP caching with respect to Spring Boot. Now, HTTP related, caching header, or you want to integrate certain, caching mechanism. We have some service workers, like we have in the front-end applications like React and Angular, right? So at the controller level, when you're defining this particular thing, you can define the cache control, right? What is the maximum age of this? Like, let's say it is 1 hour. We can define this. Now there are different caching strategies. Okay, one is like cache aside with the application. The application is responsible for loading, and reading, actually read through, write through, and then write behind, I would say. Now, can you tell me the approach of integrating the test cases in your front end and the back end, right? Now, how do you set up that? How do you configure your test environment? How your dependencies are, done, and then how to end function you'll be able to test it. Okay. Now let's discuss about, like when you're trying to integrate the testing inside the UI and the front end in your Spring Boot application, what all settings are required, what all configuration with respect to the test environment are required, what mock dependencies we can add up, and write an end-to-end test case. Okay, the very first thing is that we have to do the backend testing. So you have unit testing and the integration testing. So we have to make use of the JUnit testing framework, that is either JUnit 5 or framework 4. So based on your that, and we can use it. We have a Mockito for the mocking certain dependencies, and then you are trying to test that particular individual components. First is that you have to add the dependencies. We already discussed the starter test. Second, you have to extend. You have to define the particular Spring Boot test class, and then you have to annotate with extend with that particular Spring extension, and then you have to define some mock beans over there. You have to auto-wire the service. Then you have to define a method where you have to test that particular method. So at the rate test is used for denoting that. Under that you will be writing that particular conditions to write test that. Now we have an integration testing as well. So at the rate Spring Boot test also provide an entire application to be tested in the context. So we have at the rate web MVC test for testing the controller specific. Now if you see at this particular code, the controller, if you want to test it, right, when you are invoking the API slash data endpoint, and then you are going to return or you are going to expect a okay result over there. So that's where you can write the test cases by defining at the rate test method. Front end, actually you want to test it or you want to integrate that particular testing, what you have to do is that we can make use of the Selenium, or we have a Spring Boot test rest template. Okay, so we can make use of that. What you have to do is that Selenium related thing. What you have to do, you have to add the dependencies. Then you have to test it with the in the run with Spring Runner. Under that, you can define your random code and other Spring design, and then you can test. So you can test whether if you see a web driver, we have defined the local host. Then you have find by element, and then it's going to assert it over here. That's where you can test it. Now, third is mocking the dependencies. We already discussed, like, let's say you want to do, mock some certain extent dependencies like test in the environment. You have databases, services, external services, or beans. So you can inject them using the Spring context at the now end-to-end testing. Basically, you have to ensure your entire application from the front end, back end, everything is integrated, and then you tested your functionality. So we can make use of the REST template, I would say. So whether we can make use of that this thing. So if you see here, we have different define over here. We can to assert it over here. We have to assert equal over here, right? So REST template is going to you make use of that, and then we can test it. Now, how do you work on the microservices? Now, in microservice architecture, where their application is broken into different and smaller, manageable, independent services. So each service is going to handle some specific task, okay, or business functionality. So one of the important components, I would say, of microservice application is like Spring Boot, where is required, right? So it is used for building the microservices. So it is going to run your application independently, and then you're going to communicate over the HTTP. Spring Cloud, this is one of the tools used for building and managing microservices. Now, which will include config, Spring Cloud config server is there, Eureka server is there, gateway is there. So, you have a circuit breaker design pattern, which is for fault tolerance. Then we have a sleuth for distributed tracing. Now, when you're communicating, we have communication as well. Like we are using the REST endpoints, or you're using the gRPC for asynchronous communication. Now, asynchronous way we can make use of the message broker, uh, also like Rabbit or a Kafka. Now, you want to manage some database, right? You have to have your own database. So we have Spring Data JPA, which will be used for each with the help of the service, right? So when you're designing a microservices, it has to be flexible, it has to be scalable, it has to be independently deployed for each of these particular services. Now, what are the different type of inter-service communication is happening, and like let's say the two microservices, how do you communicate asynchronously and synchronously? Okay. Now let's discuss about this synchronous way. As we already discussed, microservices are communicating in both synchronous and asynchronous. So synchronous is basically when you are using the REST endpoint, or we have this particular HTTP request being called out, right? You are directly calling the particular service over there using the REST endpoint. Now it will have to wait until that particular response is returning to it. Okay. Now you are making a call, let's say for the HTTP request. Let's say you're calling service A is calling service B. So you have to wait for the response. Now with respect to gRPC, this is going to be a high performance framework which is based on the HTTP version. So it is handling your request in a better way, I would say, in some cases. I would say. Now, what will happen is that now we have another term which is GraphQL. Now, this is used for querying your data from the multiple server into a single request. Okay, so it is going to allow your client to be, provide some specific data in a different from the different services. So that's the benefit. In a single graphical call only, you will be able to perform different operations over there. Asynchronous communication we already discussed. We have Kafka or RabbitMQ. So this is one way, like service is going to send the message to certain queues or topics, and that then after that it is going to consume some data from there the services. Okay. Event-driven architecture, basically in microservice architecture, we are using event sourcing example. So we are trying to emit something. The service is going to communicate to that particular service, or the I would say the where it is going to consume that particular event. So it is going to publish certain events, and the listener is going to listen that, and then you have to perform that asynchronous operation on top of that. Okay. Now we have public subscriber model as well. Now this service is going to publish some message and into a certain topic, and then whatever the services are interested to that particular topic, it is going to consume that, and then it is going to perform some action. Now, let's say you wanted to work on the distributed microservice application, then you want to do perform some I mean you're trying some you're facing some issue I would say, uh, like some performance issue is there. So you have to understand like where the flow is coming. How do you implement? There is a AWS X-ray which is going to collect some data from the microservices. Now, for diagnosing or some backtrace some performance issue in your distributed microservice application, we can make use of this particular tool called AWS X-ray, or there is a Jaeger or a Zetkin, right? So we can make use of it. Okay, we have using the AWS for X-ray. It is going to integrate. There is an SDK for it, okay, which is supporting the Spring Boot microservices. Okay, you have to add the dependency, and then you have to make use of it. Okay, there are some configuration also we need to define. Okay, Jaeger, this is your distributed tracing. Now, if you see, this is going to be the IO, right? And then it is going to be configuration. So, yeah, it is also having a UI for it, where you can actually use some traces, use some latencies reports in that particular UI as well. Now, distributed tracing, basically when a client is requesting some request, right? So there will be some unique ID generated. Okay, so all this particular service A, B, and C, the aggregation is going to track that particular tracing, and it is going to make use of that particular thing. Okay, we can make use of the Prometheus or Grafana, which is used for tracing, or it will collect some monitoring details, how you are, what is the response time, what is the error rate, etc. And is going to display in the visual form in a better way. Now, how do you, have you worked on the REST endpoint, REST API, and how do you implement versioning in this particular thing? So, REST endpoint, when you are trying to implement, we have a different API versions. So, let's say you have a different version maintained for it, so that let's say you have defined some services or functionality to it. Now, later on, you have modified it and then provided a new version of it. So, in this way, you have to provide a versioning so that there is a backward compatibility for the other services which are not completely migrated to them. Okay, so we have the different approaches. Basically, first one is URI path versioning. So this is one of the common way where you have in the URL itself you can define this particular version. Okay, that is the best practice I would say. Second is like request param. So in the request param itself, like define that particular value, right? What is the version number over there? So the version number one, then you can execute certain logic over there. Okay. Header, in the header you can pass the version related things. So in the at the request header, you will get that particular API version, and then you can act accordingly. Then comes like content negotiation, where you have this particular API version based on certain accept and header, right? So in the accept header, we will be able to get that details. So in that, you will be able to check that. Now, have you worked on the CI/CD pipeline when it comes to microservices? Do you have knowledge on that part? Now, CI/CD pipeline, there are different Jenkins, GitLab tools, right, which are used. Now we have also tool CD to the, I would say Kubernetes is there, Docker is there. In AWS we have code pipeline. Now there are different stages, I would say. Code commit is there, build is there, everything is there, and then deploy, right? So these are the different stages, I would say. We make use of it. Now, code commit, you are going to commit on certain repository, that is GitHub or GitLab, right? Then you are going to build that particular build. Now you can make use of the Docker images. We can make use of the Maven for building the microservices. We have certain sonar cube checks which are done at the analysis at the when you are scanning your CI/CD pipeline. It is going to run your integration test cases and the unit test cases. It is going to containerize your application. It is going to push to certain registry basically. Okay, so these are the steps which are happening, and then comes the deployment. So you want to deploy it on the Kubernetes, Docker, etc. So this will be going to happen, and then comes the monitoring where you have to check, like what is the ELK from the ELK stack or the Prometheus. You are going to check, and then you can implement certain strategies in case of failures. When it comes to microservice specific, like you have service discovery, we can make use of API gateway, we can make use of configuration management, right? So when you're using the pipeline with the Jenkins, okay, so there is the steps are like build stages there, automated test cases are there, build Docker is there, deployment is there. So these are the steps. Now, here if you see, how do you write the JUnit test cases? Like say for the factorial thing, let's say you have a factorial number, you have implemented certain class, and then you wanted to write a test cases for it for calculating the factorial number. How do you do that? Now, first you have to have your own functional class written over that. Then, in order to implement the test cases, you have to write the, let's say, JUnit test case. You have to implement the, add the dependencies. Then, what you can do is that you can define your at the rate test method. You can define certain assertion inside that, okay, and then you can test it. Now, there are different assertion, assert throw, assert equals. You can test that. So here you can check for, like different ways of setting, testing with the zero, testing with the positive cases, testing with the negative cases, testing with the large number, testing with the, like single thing. So these are all the different negative positive scenario you have to test. Now, coding challenges. uh, in every interviews, either it's going to be a start of the section or in the middle of the section or at the end of the section. So in this particular interview question, this was the a question where it was asked, like we have an, let's say, integer list from, let's say, 1 to 10,000. It has got some duplicate elements at it. Okay, I wanted to write a Java program to find return all the duplicate elements only. So this is one of the important question, I would say. So make sure you are well prepared for this. Then comes sum of an even integer. Now, first of all, the list will be provided from last 1 to 100. Now, using that with the help of Java 8, you need to find the sum of all the even integers without using the sum method, basically. Now, I would say, like when the interviews is done with the questions, right? Like when he is satisfied that yeah, I'm done with the interview question what he has, right, and he is satisfied with the person, or let's say he's even is not satisfied, he will go to the section of, asking, like post interview questions, like he will expect an the candidate to ask certain questions. Okay, so he will give a chance to the interviewee so that if he has some questions or some doubt, he can ask. Okay, so basically, the question we can ask about is, like what kind of projects we are going to work on, what is the domain we are going to work on, right? These are the question which can we can ask. Second, like you can ask for an area for an improvement, like what are the things where I would say, I know, like the interviewer will be really little bit reluctant to answer this, because indirectly this is kind of giving an feedback or a suggestion to him, which indicates that in certain area he has not performed well. But basically you can ask in a polite and a different way that what are the areas of improvement. Okay, I hope this video was very helpful to you. I tried my best to give you all the answers with respect to the questions which were asked. Okay, and these are the real interview questions which are asked, so that you can well prepare for your next interview.